Hello, everybody, and welcome back to the week of October 12th. We are going to be doing we're going to be looking at parallel and perpendicular lines this week. So I don't know, maybe you thought you got away from dealing with slope-intercept and all that graphing equations, but we're back. That's right, it's coming back to haunt you. We're going to go over a little bit. Let's do that now without further ado. So I'm going to drag myself off screen and let's take a look at parallel and perpendicular lines. All right, I got myself a little graph here. So all that we're doing in this next unit is parallel and perpendicular lines. Let's look at what it is that makes a line parallel to another one. We're going to start with parallel. So let's say I have a line. Now remember doing this. Remember how to get the slope of a line. Let's make a line with a slope of 1/2, but a y-intercept of -1. So it would have the equation would be x. Oh, darn it, I was on the wrong thing. Let's drag my thing back over here. Okay, so it would be, the equation would be x equals 1/2 minus 1, right? So then we start here at -1, and then we go up 1 over 2, and we go there. We go up 1 over 2 and make another dot. I like to make lots of dots because I am terrible at drawing. So it's easier if I have a lot of dots to keep myself kind of along the line. There we go, right? 1/2 minus 1. How would I make a line parallel to this? Remember that a parallel line never touches. So it's better if you don't overthink this one. If I make a line that has exactly the same slope, but a different intercept. So how about if I make one that has, let's do my other line in a different color, and I'm gonna make its y-intercept. How about if I make its y-intercept 2? But the slope stayed the same. So my equation would be y equals, oh gosh, did I forget to put a little x there? Did I confuse you on that one? 1/2 x, there we go. All right, the next one is gonna be y equals, still the same slope, 1/2 x, but different intercept, +2. So let's take a look at how that one works. We go up 1 over 2, up 1 over 2, up 1 over 2. Let's go down 1 over 2 just to figure this, get this all fleshed out. And what you should probably see from these lines, assuming that I could actually draw a straight line, which I cannot, but let's just imagine that they're straight lines, okay? Humor me a little bit, folks. If we were to look at that, you know what? I could just keep drawing these lines. I could just keep continuing these two lines forever. And you know what? They would never touch. So knowing that they will never touch, I can guarantee you that these two lines are parallel, right? Parallel lines never touch. So if two lines have the same slope, remember the slope is the fraction that's right before the x. If that slope is the same, they're parallel, they will never, ever touch. Now, let's take a moment to look at perpendicular lines and how perpendicular lines work. A perpendicular line, first of all, is a line that meets at a right angle. I don't think we went over that. So I'm gonna do a little Control Z here and a few times, see how much it'll erase. This is kind of fun. Hopefully you're hearing all the clicky clickies. All right, so let's pretend all that never happened. Cool. Now let's take a look at perpendicular lines. If I have two lines, let's just say these are straight lines again, and they meet at a 90-degree angle, meaning you could draw that little 90 degrees, that means they're perpendicular. Perpendicular means they're perfectly meet at a right angle, which, just for the fun of it, it's important for us to recognize that these x and y axes are always perpendicular. They always meet at a right angle. Even if it's imagined, it's always perpendicular. And remember, we always mark it with that little box, but you don't have, but, oops. Shift-C. All right, what? There, okay. Now, let's look at what makes a perpendicular line. Perpendicular lines are a little bit different. If the slopes are what is called the negative reciprocal of each other, if their product equals -1, That sounds complicated. What happens if we multiply 1 times -1? That's right. It equals -1. All right. So what if I had another line and I go, let's say I have one line that's got a slope of, 1/2. And another one that has a slope of -2. What is 1/2 of -2? That's right, -1. Now, let's actually imagine graphing some of these lines, okay? Let's go ahead and create a line that follows this equation. We're gonna graph two lines. Y equals -x plus, I don't know, let's just give it a y-intercept of 2. And then another one, y equals x plus, I don't care, 1, y-intercept of 1, because we have fun here. All right, now let's take and graph the first one. So we start at +2, and then we go down 1 over 1, because remember, it is -x, so -1 over 1. -1 over 1. -1 over 1. Oop. All right, let's just continue it just for good measure. Okay, line through there. Got little arrows on it, shows it goes forever. And then we go, it is x plus 1, so we start at 1, and we go, what? Boop, boop, up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. Continue it this way, just to make drawing it easier, because you just can't trust what I draw. I need guides, I need help, because my drawing's terrible. If my drawing wasn't so horrible, we would be able to see that these two lines meet at a right angle. If you were to take a protractor out and measure it, you would see a right angle. Cool. Let's try it with some more complicated lines though, because these ones, let's be honest, they're not very complicated. And I want to make things as complicated as I possibly can for you. So let's take a look at if we were to choose two different equations. So how about y equals -1/2 x plus 3, and y equals 2x plus, I want a minus, 2x minus 4. Aha. All right, let's graph the first one. So we start at a y-intercept of 3, because we had +3. And we go down 1 over 2. Remember, negative slope. Down 1 over 2. Down 1 over 2. Down 1 over 2. And then let's go like that. And let's go like that. And let's go like that. Okay, cool. Now let's go ahead and draw this line, even though we know the outcome is going to be that Mr. Hoffman cannot draw a straight line. That's okay. Then we're gonna start at -4. 1, 2, 3, 4. Draw our little dot there. And we're gonna go, 2, up 2 over 1. Up 2 over 1. Up 2 over 1. Yeah, I got that. Okay, up 2 over 1. Up 2 over 1. Yeah, that's right. We're stuck in the middle there. Okay, so let's take a look. Let's draw a line and see if they look like they probably, even if, assuming Mr. Hoffman could draw straight lines, would those, look at that. Look at that. They are definitely perpendicular lines. So if you can, say we had two lines where the slope was y equals 1/3 x, and then we had y equals -3x, and we went 1/3 times -3 over 1. Guess what? 1/3 of -3 equals -1. If the slope is -1, or excuse me, if you multiply the slopes and you get -1, then they are perpendicular. So in the book, it's going to say the product of their slopes, which makes it sound really, really confusing. But really all you're trying to do is, all that means is that this times that, right? The product is the result of multiplication. So hopefully this helps you figure out the questions in the book, makes it a little bit less unclear. Clear as, maybe if not clear as mud, maybe clear as reservoir water. Once again, you can contact me over Google Classroom or email, or you can ask me during our class period if you have any further questions about this. But for now, there it is. It's that simple. And I'm not going to assign a very long assignment, but you know what, guys? You know what? I need you to start turning your assignments in. That's the big thing. Because you know what? Yes, I checked the assignments. I checked the list in what's that called? In Savas in the book, and it looked like 3 of you had completed it. It was due yesterday. Today is Sunday. Yesterday is Saturday, and it was due, and you didn't do it, which is really disappointing because I was hoping that you would. But I will see you in class tomorrow, during which I will also chastise you for not turning things in. And hopefully you'll take this opportunity and the explanation that I've given you to work on this week's assignments. I will see you in class tomorrow.